The remainder theorem is very easy. Let's say we have this polynomial f of x equals to 5x cubed minus x squared plus 13x plus 29.
Yeah.
And we want to find out what will be the value of this function when x is equal to -4. So that means we want to evaluate f of -4. So if you don't know about the remainder theorem, then you would do 5 times -4 cube minus -4 square plus 13 times -4 plus 29. Right? That's how you would find out the value of f of -4.
Yeah.
But if you know the remainder theorem, then remainder theorem says that f of -4 will actually give us the remainder when f of x is divided by x plus 4. If you divide this polynomial by x plus 4, then whatever remainder you'll get, that will be the value of the function. Okay, so we are going to verify this statement. First, let's calculate this, all of this. Like let's just simplify this expression. So what is -4 raised to 3? -64. And that times 5. So -320 minus -4 square is 16. Then 13 times 4, 52, plus 29. So this will be, so this is going to be -359. Okay?
Yes. Yeah.
Now, instead of doing this, we will now play smarter and you'll just find out the remainder using synthetic division this time. Okay? So we'll write -4 here. Coefficients of the polynomial, 5, -1, 13, 29. Copy down 5. So -4 times 5 is -20. So write that here. Add them. -1 plus -20 is -21. Now -4 times -21 will be +84. Add these two. So 13 plus 84 will be 97. Then -4 times 97 will be -388. And add them. So if you add these two, you get -359. And this is what? This is the remainder.
Oh, wow.
So this is what we got when we evaluated the function manually, right? This answer we got when we evaluated the function manually. And this is what we got using synthetic division. So that's your remainder theorem. Remainder theorem says that if you divide a polynomial, if you want to evaluate a polynomial at some number, so you can do that using synthetic division. So I'll write the statement of this theorem. It says that if a polynomial, and this is very important, remainder theorem, if a polynomial f of x is divided by x minus k, then the remainder is, can you tell me what will be the remainder? Then the remainder is f of k. Now you can also do the opposite of this theorem. This time we wanted to evaluate the function, so we found the remainder. And if you want to find out the remainder, then you can evaluate the function. So it is useful both the ways. For example, let's say Okay. Let's say we have a polynomial f of x equals to. Did you understand the remainder theorem, Aditi?
Yeah, I'm just trying to now understand the opposite of it. So I'm kind of.
Opposite of it. Yes. Okay. So first of all, on this screen, we wanted to find out the value of the function. This one, value of the function. So we found the remainder. Okay. Now, if you want to find out the remainder,
We need the coefficients or the x?
then we will evaluate the function. Right? So
Oh, okay.
4x squared minus 10x minus 21. Okay. So we want to find out the remainder when f of x is divided by, let's say it is divided by x minus 1. Find remainder. Okay. We want to find out the remainder when f of x is divided by x minus 1. Now you would say that, okay, I know synthetic division, so you would divide it using synthetic division for negative 10, negative 21. And here you will write 1. Okay, can you tell me the next steps?
Can I write this down?
Yes, of course.
So you bring down 4, 4 times 1, 4. So then you can get negative 6. And then negative 6, so 21 plus negative 6 is negative 27. Okay. Okay, so the remainder is negative 27.
Yes, this is what we are getting from synthetic division. But in this case, I think it would be easier to just evaluate the function at x equals to 1. That's what remainder theorem says, that the remainder is f of k. What is k? K is the 0 of the divisor. If you put x minus k equals to 0 and you solve for x, you'll get x equals to k. So if you just evaluate the function at k, even that will give us the remainder. So here, that would be easier. So this is your divisor. Set it equal to 0. So that gives us x equals to 1. Now, if you evaluate the function at x equals to 1, I think that would be easier in this case because it is 1. So 4 times 1 square minus 10 times 1 minus 21. So this will be 4 minus 10 minus 21. 4 minus 10 is negative 6 minus 21.
Wait, get that again?
Wait, what? Which step?
F of 1, that's it. F of k, so.
So you have to set the divisor equal to 0. That's your divisor. You want to find out the remainder when f of x is divided by this polynomial. So this is your divisor. So to find out your k, you will set your divisor equal to 0. Okay?
Yeah.
So x minus 1 is equal to 0. And from here, you will solve for x. So that gives you x equals to 1. So this is your k.
Yeah.
Okay. Now to find out the remainder, you can also find out what will be the value of the function at k. So f of k or f of 1.
Yeah, okay, that makes sense. Yeah.
Okay. So f of 1 will be this. You just have to substitute x by 1. And that will also give you negative 27. Okay. So you can do both the things. Here what we did, here it was easier to do synthetic division. So here we wanted to evaluate the function at negative 4. Okay, so doing it manually was kind of tedious. So instead of finding out the remainder manually, we used synthetic division. And here we wanted to find out the value of the function. Sorry, here we wanted to find out the remainder. So instead of using synthetic division, we evaluated the function. basically you can do both the things. You can evaluate the function, okay, or you can find out the remainder at a certain point. So f of k will give you both the things. The remainder when the polynomial is divided by x minus k, or if you want to evaluate the function at k, both the things will be same. Okay, that's your remainder theorem. Okay, so let's do some challenging problem. Not some, but just one challenging problem. And this kind of question is, you can expect on SAT.
Oh man.
Okay, so what is the value of k? What is the value of k such that x cubed minus x squared plus kx minus 30 divided by x minus 5 has a remainder 0. 0. Okay, and yeah, that's it. Well, you have answer choices as well, but I'm not writing the answer choices. Let's say this is a free response question. So we have to find out the value of k when, if you divide this polynomial by x minus 5, you get remainder 0.
Mm-hmm.
Okay.
Yes.
And obviously, since we are doing remainder theorem, so you know that you need to use the concept of remainder theorem.
Wait, don't we do f of 5?
Yes, exactly. F of 5. So f of 5 will give you what?
F of 5 is equal to 0.
Perfect. Well, f of 5 will give us the remainder, and that is 0. Exactly. Okay, so we can put x equals to 5 in this polynomial. Okay.
Mm-hmm.
So 5 cubed minus 5 squared plus k times 5. So if I write 5k minus 30 equals to 0. 5 cubed is 125 minus 5 squared is 25. And I'll write negative 30. This is equal to, I'm subtracting 5k from both sides.
Oh, okay.
So 125 minus 25 is 100.
Minus 30, that's 70.
Hmm.
Divided by negative, okay, that's negative 14.
70 divided by negative 5. That will be k. So value of k is negative 14. That's it. That's the final answer. K is equal to negative 14.
Yay.
Okay.